I mean, can you believe it? This is like seeing like a double rainbow or triple rainbow. You have two sections in a row, 6-2 and 6-3, that both have 3 videos each. You are just lucky. Okay? Count your lucky stars, geometry kids. All right, here we go. So theorem 610 covers the diagonals. So it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. You learned this word bisect way at the beginning of the year. Remember, bisect means 2 congruent parts. So the diagonals are segments. They bisect each other. They break each other into 2 congruent segments. So in this picture here, we have a parallelogram. Opposite sides are parallel. So what this means is WY, segment WY, and segment XZ bisect each other. So A to W is going to be congruent to A to Y. And then A to X is going to be congruent to A to Z. Now notice I used single marks here and double marks here. The diagonals are not congruent. WY is not congruent to XZ, right? There's no theorem that says the diagonals are congruent here. But the diagonals themselves are broken into 2 congruent pieces, right? Okay, so if we take a look at the Savas idea here. All right, so again, if you can see 3.3, 3.3, 5.6, 5.6, obviously if you add those three, if you double 3.3 and double 5.6, those diagonal lengths are not the same, right? Obviously. If I drag W out a little bit more there we go, nice little 8 there. There we go, and a nice little 5. Look at that, perfect, right? 8 and 8, 5 and 5, still a parallelogram, but again, this diagonal would be 10. This diagonal would be 16, not congruent. All right, so I think we're going to try to go ahead and prove this in the next slide here. All right, good times. So it says, how are the diagonals of a parallelogram related, right? So we know how they are, right? We just learned. So we need to prove this relationship here, okay? So again, when you do this, it takes proving that triangles are congruent. We are going to, and notice they drew both diagonals. We're going to prove these 2 triangles here, this one and this one, congruent. And if we do that, the pieces of the diagonals are going to be corresponding parts of those 2 triangles. Okay? Now, to do this, we're going to do what's called a flow proof. You've done them before. So we're going to do a flow proof. First, we start with the given. So I'm going to start with the fact that we have a parallelogram way up here. Parallelogram A, B, C, D, and that's given to me. Okay? So from there, right, I'm going to come over this way, right? We have parallel lines. Now, the only parallel lines I have to talk about are AB and CD because they touch angles 1, 2, 3, and 4, the angles I'm going to use. So we know because it's a parallelogram, AB is parallel to CD. And that's by the definition of a parallelogram. So because of that, if I trace AB in red, and then let's do diagonal AC first, angle 1 and angle 4 will be congruent. So from here, I know that angle 1 is congruent to angle 4, and that's because they are alternate interior angles, so there's a theorem there. If I do the other transversal, now I know that angle 3 and angle 2 are congruent. So I know that angle 2 is congruent to angle 3. That's also by the alternate interior angles theorem. And between those 2 triangles, that's 2 angle pairs. Angle pair 1, angle pair 2. So now I need something that is also congruent, preferably a side, right? And I can use angle, angle, side, or angle, side, angle. Well, this is a parallelogram, right? Aside from being parallel, the opposite sides are also congruent. So I can also mention that segment AB and segment CD are congruent. That comes back from the given, right? Segment AB is congruent to segment CD. And that's because opposite sides of parallelogram are congruent. Right? That's one of the properties. That's an arrow. And that is the side pair I needed. And now these 2 triangles are congruent by angle, side angle. So what I'll do here is I'll be, a little creative, right? I'm going to bring this down here. I'll arrow this over there, and then this one I'll arrow over here, because these three statements all contribute to the fact that the triangles are congruent. So now I'm going to name them correspondingly. Triangle ABQ is congruent to ABQ is congruent to triangle CDQ. And that would be by angle, side angle. So now from here, I now believe, if you look at these segments we have to prove congruent, I believe these are corresponding parts of our triangles. So I think from here I can prove that segment AQ is congruent to CQ because they're corresponding parts. And I think I can prove that segment BQ is congruent to DQ because they're corresponding parts of these congruent triangles. And I've proven what I had to prove. I've proven that these parts of the diagonals, AQ and CQ, are congruent. I proved that BQ and DQ are congruent. I have proven that AC and BD bisect each other. So thus, segments AC and BD bisect each other. So hopefully now you believe that these two diagonals bisect each other. All right, very good. Okay, so let's do one example problem, and then we'll be done with this video. Okay, so it says Corey stamps the orange and purple pattern shown on the front of a poster she is making. How many times will she need to stamp the design to make a row 60 centimeters wide along the dashed line? Okay, so basically what it's saying is, right, we need to find how long AX is, XC is, how long this diagonal is, right? That's going to give us how many times we have to stamp this stamp, right? So again, it's important to understand that these are the diagonals. AC is the diagonal. So first off, we know that the diagonals bisect each other. So I did overlook the fact that it is a parallelogram, yes? So because it's a parallelogram, the diagonals bisect each other. Now they do tell you that x to d is 4, right? So x to d or d to x, this is 4. Well, if the diagonals bisect each other, then d to x is the same as b to x. So bx is also 4. So since dx equals 4, bx equals 4. And it tells you that ax, which is this length right here, AX along the dashed line, is 1.5 times BX. Well, if BX is 4, you just take 1.5 times 4. And 1.5 times 4 is 6. AX is 6. And again, the diagonals bisect each other, so if AX is 6, so is XC. This is 6 and 6. And to find the length of AC, AC is just going to be 6 plus 6, which is 12. That's the length of the diagonal that goes along this dotted segment. We need to see how many of these parallelograms we have to stamp next to each other to make 60 centimeters. So we're just going to take 60 and divide by 12, because each stamp is a length of 12 along that diagonal. And 60 divided by 12 is 5. So if we put one more here, one more there, if we put one more there, one more there, we will have that pattern. So we need 5 stamps. Good deal. All right, thanks for watching this third video, and we'll see you in class.